Without the gangway, the vessel basically is a floating hotel. A gangway like this, it is referred to as the money maker on the vessel. So we need to have a gangway system that is very reliable, and it needs to work 24/7.
This is Greg Trotwine with Maritime Reporter TV, and we're very pleased to be here in Oslo at North Shipping 2025, and we're with Bjørnar Berge of MacGregor, and we're here to talk about some offshore solutions for the offshore wind industry, specifically MacGregor's unique gangway solution. So Bjørnar, just to start us off, why don't you give us a brief history of your career at MacGregor with insights on your responsibilities today?
Yeah, thank you. I've been with MacGregor now for nearly 3 years. As a senior sales manager dedicated towards the offshore wind industry normally, where I handle the sales from basically when we have a request, working with the stakeholders, trying to promote our products, and eventually signing the contract and handing it over to our project team. So that is kind of my core responsibilities within MacGregor.
You know, we're obviously here to talk about your unique gangway solution to the offshore wind industry. Yeah. And again, I'm certainly not looking for you to disparage the competition necessarily, but why don't you talk a little bit about the gangway solution and specifically what makes it stand out?
Yeah, definitely. So the gangway solution from MacGregor was developed back in 2018. And I think when we started, we took obviously the background from oil and gas and the heave compensated cranes, which had the heave compensated technology that is required for also the gangway systems to transfer cargo and personnel across to the wind turbines from the vessel in a safe manner. So when MacGregor started to work on this gangway system, we decided upon what was the crucial factors for the ship owners when deciding upon a gangway system. And there were 3 kind of main topics that stood out, which was safety, efficiency, and reliability. And that's kind of the 3 themes that we wanted to deliver upon. So number 1, safety. How do we deliver upon the safety factor? So what we did is we introduced a redundancy level that is higher than the class requirements. So what that means is that we have 2 independent switchboards, which both are kind of ready to feed power to the system. So if one side fails, the other one will be able to take over the complete operation with the same power as the other side. And this redundancy level then exceeds what is the class requirement for these kind of systems. And that raised obviously the safety level of the systems, setting a new standard within this gangway market. And then furthermore, we wanted to introduce, to deliver on the efficiency aspect, we introduced an all-electric gangway with all the rotary motions being delivered from electric machinery in the form of winches. And that helps a lot with regards to the efficiency aspect, where you get the best response. And this is a very active compensation where you have to compensate constantly towards the turbine. So to have a precise and very responsive compensation was required, and that is where you get the best from the electric drivetrain compared to, for instance, an hydraulic drivetrain, which was the standard in the industry at that time. And furthermore, we introduced permanent magnet motors, which is a very sophisticated motor delivering the best kind of torque ratio. Even at low speed, you get very good torque, and that is very good when it comes to the response rate of the system, delivering upon that efficiency aspect. And then finally, we introduced a different geometry of the gangway system. So normally the luffing motion of the gangway, all the competitors would control that from the back of the gangway systems in a form of a cylinder controlling that luffing. And that gives you a few kind of downsides with regards to how precise you can be 20 to 30 meters out, where you want to keep the tip of the gangway still relative to the world. So we basically place the winches on top of the tower on the gangway, and then it comes down 2 wires taking control on the middle of the bridge, controlling the luffing motion out on the bridge. And that gives you a huge benefit when it comes to how precise and how good you can keep the stability of the heave compensation. And all those things basically meant that we felt that we delivered on that efficiency aspect, that you get the most efficient gangway possible. And then I guess reliability, it needs to work on a CSOV. which is this commissioning service operator vessel, where you normally would introduce a gangway like this. It is referred to as the money maker on the vessel. So without the gangway, the vessel basically is a floating hotel. And that is not really what you need. So we need to have a gangway system that is very reliable, and it needs to work 24/7. So in order to do that, obviously this dual path philosophy, as we say, with the redundancy level, that you have very good high redundancy level, is obviously a main factor. But then we also introduce OnWatch, which is MacGregor's aftermarket service, where we are connected to the equipment and you get 24/7 support from MacGregor, where you can call and get expert help. We can connect remotely and look at what is the issue, if you experience any issue, and solve it obviously as quickly as possible.
Can you take a little bit deeper dive, though, into the electric versus the hydraulic? Because I found that actually to be quite an interesting development. Again, I know you described it, but I mean, what are the real bullet points? What are the key factors of electric versus hydraulic?
Yeah, I'd say from a ship owner's perspective, you want to keep the operational expenditure of your vessel as low as possible. And one of the mission equipment, like the gangway systems, to have an all-electric gangway which can regenerate power back into the grid, and you get a much better energy efficiency compared to a hydraulic system. So that is kind of the main factor when it comes to deciding an electric versus an hydraulic, where you get obviously a more kind of emission-friendly system, which is also in line with a big focus from the financing of the vessels. The banks are looking at what are you doing in order to stay green through the supply chain. So to deliver upon that from a ship owner's perspective, we wanted to support them with an all-electric gangway that can regenerate power into the grid, help keep the emission down, and help keep the kind of operational expenditure of the vessel down. And then you get obviously the benefit of it being more efficient than a hydraulic system, also in operation. And what that means is that when you have a compensation that is so precise and so stable, you can also tackle more harsh sea states. And for a CSOV, you want to increase the weather window of when this vessel can actually operate, because normally an SOV traditionally have only been able to work through the summer season, so starting from May till September. So you have 6 months there where the vessel is not capable of basically doing the work required. And what we wanted to do is increase that weather window, because the commissioning of the wind farms ideally would go 12 months and not have this winter break. And setting a new standard for what the gangway systems are able to operate in was kind of the mission. And based on now operational feedback and operational data from the largest wind farm in the world, Dogger Bank, where we have 2 vessels now operational, we are top of the charts when it comes to delivering on that promise, where we are basically operating at a higher sea states than what has been kind of the norm in the industry. And the earnings of the vessel obviously then also goes up, and it becomes a win-win scenario where the ship owner also can commit to a contract in a higher sea state and keep the weather window basically at a lot larger extent than it used to be.
You know, as you said, it was developed specifically in 2018. Obviously, a lot of technologies for offshore wind started in oil and gas. Are there significant or are there notable differences between a gangway for oil and gas operations versus wind operations? And if so, can you kind of point them out?
I think in the oil and gas industry, they would normally stay permanently connected. Yep. And it will be like a walkway that personnel can walk through at a given time. So it's a slightly different setup when it comes to how it is connected, because then it is permanently connected on normally a cone landing, which you would land the gangway on, and it would stay permanently connecting, more of a passive compensation. Mm-hmm. Whereas for the offshore wind, they would compare it to a pit stop in Formula One, where you have to service a lot of wind turbines at the same day, and the efficiency is very crucial. So then it comes down to what we would call the logistic flow of the gangway system. So then you are basically docking towards a turbine, and it needs to be as efficient as possible, and you want to get the cargo across, the personnel across, as quickly as possible, disconnect and move to the next turbine. So we are being challenged from ship owners on how can we support them with kind of being able to service as many turbines as possible throughout the day. So what we did to try and support that compared to kind of the oil and gas industry, where it's not the same kind of aspects that come into play, we increased the dimensions of the gangway as well. So normally there would be a width clearance on the bridge of the gangway at 1.2 meters. We increased that to 1.5 meters. And that is to try and also support that logistic flow of the vessel to be able to transfer across pallets quickly and not kind of being limited by the space that is available. And we also introduced a larger elevator, because this gangway comes with an integrated elevator in the tower that brings cargo and personnel up and down. So again, to try and limit the amount of trips you have to do up and down, we increased the dimensions of the elevator compared to what was the norm and still is the norm on the market. And that is also supporting the ship owners to be able to do that kind of Formula One pit stop where it has to go like bang, 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 and then next one basically.
As always, it comes down to the safety, reliability, and efficiency.
Definitely.
Got that mixed up a little bit, but that's okay. So, Bjørnar, I appreciate your time. I really just had one more question. So, you mentioned the Dogger Bank, and you have, I believe, two installations there. Can you, I guess, take a deeper dive into specifically the units that are being used there?
So we have one vessel from Integrated Wind Solutions that has been operating there now for, I guess, close to 8 months, I believe, which has seen significant results when it comes to the operational performance of that vessel, which is standing out. We also have another vessel from Edda Wind called Edda Boreas, also operating on Dogger Bank, which is also now, I guess, competing with the IWS vessel to be kind of best on that field. And when we have been showcased the kind of data from that wind farm, we see that our vessels is outperforming the other ones. And the operator has been able to raise the kind of threshold for what sea state. Is it acceptable for a CSOV to kind of say this is out of what is acceptable? We have to go back to port. So since the MacGregor Gangway was deployed on these vessels, they have been able to raise the threshold and see that, okay, we have now seen a new standard for what is possible to achieve with the CSOV, with a kind of next generation gangway systems like the ones MacGregor are delivering.